Right now, across California and New Mexico, thousands of tons of red chili peppers are moving through processing lines at speeds most people never see. But speed isn't the challenge. The real question is, how do you harvest millions of peppers without destroying them? Every harvest season, American pepper farms face a precision problem. A single mechanical harvester can pull thousands of peppers per hour. But if the vibration force is wrong, you lose 20% to bruising. If the sorting line runs too fast, ripe and unripe peppers get mixed. If the dryer timing is off, moisture ruins the powder. This isn't just farming. It's a system where harvest speed, sorting accuracy, drying capacity, and packaging seal all have to sync. One weak link breaks the entire chain. Most crops follow a simple rule. Wait until everything is ready, then harvest everything at once. Peppers don't work that way. Walk through a field in late summer. One plant has 3 red ripe peppers, 2 green immature peppers, and 1 cracked fruit. The plant next to it looks completely different. Different ripeness, different sizes, different stem strength. That's the core problem. Machines are built for uniformity. Peppers grow in chaos. Early mechanical harvesters failed because they treated peppers like tomatoes. They shook the plant hard, dropped everything, and moved on. The result? 40% of the crop was either damaged or left behind. Red peppers mixed with green ones. Cracked fruit contaminated the batch. Farmers lost money on every pass. The breakthrough came when engineers stopped trying to harvest everything and started focusing on one variable: vibration force. Too much force, and ripe peppers fall with stems attached, tearing the plant and bruising the fruit. Too little force, and only overripe peppers drop, while the rest stay on the branch. The target zone is narrow. Modern harvesters use calibrated shakers that deliver 3-5 controlled pulses per plant, each lasting 0.8 seconds. The vibration is strong enough to release peppers at 85–90% ripeness, but gentle enough to leave immature fruit untouched. Field rows are divided into zones. Each zone gets a separate pass based on ripeness data collected by pre-harvest scouts. Zone 1 might be ready today. Zone 3 waits another week. This staged approach cuts the harvest loss rate from 40% down to 12–15%. A difference that determines whether a farm stays profitable or shuts down. The machine doesn't just pick peppers. It decides which ones to pick and which ones to leave for the next pass.
Hand-picking crews can select each pepper individually. They check color, firmness, and ripeness before pulling it from the plant. That level of precision is hard to replicate with machinery, but hand-picking is slow. A crew of 20 workers might cover 2 hectares per day. A mechanical shaker can process the same area in under 3 hours. The trade-off isn't quality versus speed, it's control versus scale. Modern harvesters use adjustable vibration frequencies. Set it too high, and you shake off green peppers along with the ripe ones. Set it too low, and ripe fruit stays on the plant. The sweet spot is usually between 800 and 1,200 revolutions per minute, depending on pepper variety and stem strength. The conveyor belt matters just as much as the shaker. If the belt moves too fast or the drop height is too steep, peppers hit the collection bin hard enough to bruise. Bruised peppers lose shelf life and downgrade to processing-only stock. That's why post-harvest sorting is critical. Optical sorters scan each pepper for color, size, and surface defects. Green peppers get diverted. Bruised peppers go to the grinding line. Only peppers that pass color grading and firmness checks move to fresh market packaging. Machine harvesting doesn't reduce quality if the system is calibrated correctly. It shifts the quality control point from the field to the sorting line. Hand-picking gives you precision at the plant. Machine harvesting gives you precision at scale, but only if you invest in sorting infrastructure. The real question isn't whether machines are better than hands, It's whether your operation can afford the sorting equipment that makes machine harvesting viable without sacrificing grade standards. For farms producing over 50 tons per season, the answer is usually yes. Below that threshold, hand-picking crews often deliver better economics because the sorting infrastructure cost doesn't justify the speed gain.
A harvester can pull 12 tons per hour from the field. But if the transport trucks only arrive every 90 minutes, those peppers sit in the sun, losing moisture and firmness. The real bottleneck isn't in the field, it's at the factory gate. Most facilities have a receiving area designed for steady flow, not surge capacity. When 3 trucks arrive at once, the washing line can only handle 1 load at a time. The other 2 wait. Peppers oxidize. Quality drops before processing even begins. Look at the washing line itself. Water jets run at fixed pressure. Conveyor belts move at fixed speed. If the harvester sends 15 tons in 2 hours, but the washing line processes 8 tons per hour, you've created a 7-ton backlog. Then comes sorting. Optical sorters scan each pepper for size, color, and defects. High-end systems process 5 tons per hour. Mid-range systems, 3 tons. If your harvest rate exceeds your sorting capacity, you're forced to choose: slow down the harvest or bypass quality control. Drying capacity is the next choke point. Industrial dryers reduce moisture from 85% to 10% over 18 to 24 hours. If you harvest 40 tons in a day, but your dryer holds 30 tons, the excess sits in holding bins. Mold risk increases. Flavor compounds degrade. The packaging line is the final gate. Automated baggers seal 120 units per minute. Manual lines, 40 units per minute. A single slow step at the end can bottleneck the entire operation, no matter how fast the harvest was. System speed equals the speed of the slowest step. That's the constraint every operation has to solve.
Inside the factory, color isn't just appearance, it's data. Optical sorters scan every pepper at 400 frames per second. Cameras read red intensity, surface defects, and size deviation faster than any human eye. A pepper with uneven color or a bruise triggers an air jet. It's removed before it reaches the next belt. This isn't guesswork. It's computer vision applied to agriculture. The vibrating belt spreads peppers into a single layer. Each one passes under the scanner. The system compares color values against a preset standard. Red peppers with brown spots? Rejected. Green peppers mixed in? Rejected. Undersized or oversized? Rejected. The air jets fire in milliseconds. Rejected peppers drop into a separate bin. The rest continue down the line. Why does this matter? Because manual sorting can't keep up. A worker might inspect 50 peppers per minute. The optical sorter processes 2,000, and it doesn't get tired. It doesn't miss defects at the end of a shift. But there's a limit. If the belt runs too fast, peppers overlap. The camera can't isolate individual units. The system starts rejecting good peppers or letting bad ones through. That's why belt speed is calibrated to match scanner capacity. Too slow and throughput drops. Too fast and accuracy collapses. The result? Only peppers that meet strict color, size, and surface standards move forward. The rejected ones aren't wasted. They're redirected to lower-grade products or animal feed. This is where quality control shifts from human judgment to machine precision. The factory doesn't rely on experience or intuition. It relies on sensors, thresholds, and data. Every pepper is measured. Every defect is logged. Every decision is consistent. By the time peppers leave the sorting line, they're uniform, same color, same size, same quality. That's what makes mass production possible. Not just speed, but standardization at scale.
Fresh chilies carry 80–90% water content. That water is the enemy of every grinder, every conveyor, every packaging line downstream. Push wet chilies into the mill too early, and the powder clumps. The grinder bogs down, the line slows. Storage time drops to weeks instead of months. Over-dry them, and the color fades. The aroma weakens. The market value falls. Moisture level is the real clock inside the factory. It decides how fast the grinder runs, how fine the powder gets, how long the product sits stable on a storage shelf. Most facilities target 10–12% moisture after drying. That range keeps the powder free-flowing, prevents mold growth, and locks in color and capsaicin concentration. The drying room is where this control happens. Hot air circulates at 50–60 degrees Celsius. Chilies spread across mesh trays in thin layers. Airflow moves constantly to pull moisture out evenly. Sensors track weight loss in real time. When the batch hits target moisture, the system cuts heat and moves the chilies to cooling racks. This step is not passive, it is active precision. The factory does not wait for chilies to dry on their own. It forces moisture out at a controlled rate, matching the downstream capacity of the grinder and the packaging line. Chili powder with 10% moisture grinds cleanly. It flows through hoppers without bridging. It fills bags without clumping. It sits in warehouses for 12–18 months without degrading. Chili powder with 15% moisture jams the mill, spoils in storage, and costs the factory time, energy, and product loss. Moisture is not a side detail. It is the variable that sets the rhythm of the entire operation. Control it, and the factory runs at full speed. Miss it, and every step downstream slows down. The fruit that doesn't make the grade doesn't get thrown away. A portion goes straight into animal feed. High fiber, natural nutrients, no processing cost beyond grinding. Another batch becomes compost. Organic matter breaks down fast, returns to the soil within weeks, closes the loop on the farm itself. Some of it gets routed to lower-grade powder production. Not premium, but still usable. Food service, bulk seasoning, industrial kitchens, they don't need perfect color or uniform size. They need flavor and heat. This delivers both. The rest becomes food processing byproducts. Extracts for sauces, natural colorants, capsaicin concentrates. The compounds that give chili its kick don't disappear just because the fruit looks off. This isn't charity. It's economics. Every kilogram that gets redirected is revenue that would have been lost. Waste reduction isn't a side benefit, it's built into the margin. The same harvest that produces premium dried chili also produces feed, compost, powder, and extracts. 4 revenue streams from one field. That's how modern operations turn rejection into value without adding labor or infrastructure. Nothing leaves the facility as pure waste. If it came from the plant, it goes somewhere useful. That's not sustainability messaging. That's how the numbers work when you design the system to capture value at every grade level. After grinding, the product becomes vulnerable. Moisture, oxygen, and light can degrade color, aroma, and texture within days. Packaging isn't just wrapping, it's the last layer of performance engineering. Modern filling lines use volumetric dosers that measure each bag to within 0.5 grams. Moisture-proof bags are heat-sealed at 180 degrees Celsius, creating an airtight barrier that locks in freshness. Inline sensors check every seal for micro-leaks before the bag moves to the next station. Weight verification happens automatically. Bags that fall outside tolerance are rejected and rerouted. This ensures consistency across thousands of units per hour, without manual sampling. Once sealed, bags are stacked in climate-controlled warehouses where temperature stays below 25 degrees Celsius and humidity under 60%. These conditions prevent clumping and preserve the volatile oils that give chili powder its heat and flavor. From warehouse to supermarket shelves, the packaging protects the product through vibration, temperature swings, and handling. A properly sealed bag can maintain quality for 18 months or more. The entire process from field to final package is a chain of precision. Each step, from harvest timing to seal temperature, affects what the customer opens at home. Packaging completes the system. It's not decoration. It's the final checkpoint that ensures months of work don't degrade in transit. This is how industrial-scale chili production maintains quality at volume. Every machine, every sensor, every seal serves one goal: delivering consistent product that performs exactly as expected every time.
This isn't about bigger machines or faster lines. Real efficiency in modern pepper farming comes from the entire chain working in sync. The harvester setting that pulls fruit without tearing stems, the sorting line running at exactly the speed where optical sensors can catch every defect, the dryer capacity matched to daily harvest volume, so nothing sits too long or dries unevenly. Packaging seal strength matters as much as horsepower. A bag that fails in transit wipes out weeks of careful handling. Moisture creeps in, quality drops, and the product that left the farm perfect arrives compromised. Then there's the waste stream. Stems, undersized peppers, and off-spec fruit don't just disappear. On well-run operations, they're routed to secondary processing ground into animal feed, composted back into soil, or sold to extract manufacturers. That's not charity, it's margin. The machines handle volume, but farmers still make the calls that determine whether the system works. They decide when to harvest based on weather windows, not just ripeness. They adjust sorting parameters when a new variety comes through. They know which fields dry faster, which blocks need extra passes, and when to slow the line because pushing speed creates more rejects than throughput. American pepper farms that consistently hit high yields and low loss rates aren't running the newest equipment. They're running systems where every piece from field prep to final package is calibrated to the same standard. The transplanter sets spacing that the harvester can handle cleanly. The conveyor speed matches the sorter's scan rate. The dryer output aligns with packaging capacity, so nothing backs up. That's the difference between a farm that processes 50 tons a day smoothly and one that struggles with 30. It's not the machines, it's how they're used. Precision doesn't come from automation alone. It comes from operators who understand what each machine can and can't do, and adjust accordingly. A harvester can pull 10 acres an hour, but if the sorting line can't keep up, fruit sits in bins, losing quality. A dryer can run 24 hours, but if moisture levels aren't monitored, you get uneven batches that fail inspection. The farms that dominate this industry aren't the ones with the most advanced tech. They're the ones where every step is designed to support the next, where waste is minimized, not by accident, but by design, and where the people running the equipment understand the crop as well as the controls. That's modern pepper farming. Not one breakthrough machine, but a system where every component, mechanical and human, performs its role without compromise.